Now I'm just going through and tapping out all these holes. There's a lot of 4mm holes here which I probably will never use, but I figured at least if they're there I can use them if I need to. But what that means is that this step is going to take quite a long time to go through and do all of those. Okay, now I have all the holes tapped. It was actually quite convenient to have it in one block like this while I was handling it to do the tapping. And now the next step is to split all these into their individual pieces. I'm just going to do that with the hacksaw. It's pretty easy, but it will take a while. But as you can maybe hear from the rain on the roof, it's not really a flying day anyway. So I've got all these spacer blocks cut out now. They're looking all nice and shiny with the rounded edges. I just put some of these smaller plates here to test the gantry axis and the Z-axis, and it fits together really good. Seems to be nice and smooth, fairly friction free, and when you try and move it, and this way as well, of course, friction free, but when you try and move it like that, I'm not really getting, I'm getting a little bit of movement, but these bolts are not quite tightened, so it could be that. But overall it seems pretty good. There's a little bit of movement if I try and rock it that way, but again it's sort of sitting on the desk and it's not quite flat down, so it's a bit hard to tell. But I think the bars, these two bars here, are bending just a little bit when I try and move it like that. And I'm quite pleased at how these pieces fitted in here. God, it's heavy. So you can see how the bearing blocks just fit around the pillow block for the screw in the middle, and there's a nice little space for the top of the screw that holds the pillow block to fit in. And you can see I've had to file away a little bit of the bottom of this top plate here to fit around the rail mounting block. That's just so that it can move all the way to the end, otherwise it would have wasted a few millimeters of movement there. So it's looking pretty good at this point. I'm quite pleased with it so far. Although this is of course going to have to be all dismantled, and the underside of it's going to have the proper lead nut mounts for the actuation of the movement properly. And I also need to make some little plates to go onto here to mount the motors as well. Now I'm moving on to the first piece of, I guess what you might call fabrication. So this plate is going to be, it's going to go underneath there with the spacer. Actually, let me just finish cutting it so I can show you what I mean a bit better. It's going to look like this. There's a little spacer in there, and then that's 8mm and 8mm, so that's the 16mm that I need to have the difference between the height of the base of the motor and the height of where the pillow block goes on to hold the lead screw. So that's going to put that at just the right distance. Just in case that explanation wasn't quite clear, this is how the pillow block and the lead screw is going to fit, and then this connector will be here, and then with the way these spacers are set up, the motor shaft will be just a fraction of a millimeter off. A little bit tricky to see in this light maybe, but the motor shaft is about half a millimeter too low. But I'm hoping that the flexibility of this coupling thingy will be enough to soak up that half a millimeter of difference. If it's not, I might have to put some washers underneath the motor bracket just to raise it up a slight bit more. But I think it might work out just as it is. Well, I've just finished the second one of these plates now, and everything seems to be good. At least this is the first one. Fits on there like that, and everything fits pretty good. And I tried fitting the motor and the coupling thing on there, and the difference in offset between the shafts of the two things, the motor and that screw, was not a problem at all. So that coupling, this is able to soak up that little difference. I was having quite a bit of trouble getting the holes in the right place. These ones are not exactly right. Good enough, I think. But I was getting a little bit worried because my drill press is about the cheapest one you can get. And yeah, sorry about this lighting. I'll have to improve this lighting, I think. And I thought, oh, am I going to have to upgrade this drill press to get this to work properly? But turns out that I just needed to center punch the holes a bit better. So I've been using this thing that you push it down, and then when you push it right down, it sort of hammers itself. It's got a spring inside. And I just did one punch of that and then tried to drill. But it wasn't enough to make a nice little crater for the drill to settle into at the beginning. So I just hit it 4 or 5 times with this, and that opens up enough of a crater in the aluminium for the drill to settle in quite nicely. And after that I haven't had any problems at all. It's been going really nice. So these set of 6 holes here will be for those rails there, and they can slide up and down on there a little bit. Maybe it may be necessary, probably not, but it lets you adjust the distance of the motor away from that screw there. I've just made a rather fortuitous discovery. These lead nuts that have these 4 holes around them, I hadn't really thought too much about how I was going to attach them to the bracket that they need to go on, and the holes there have no thread in them. But I measured the hole diameter and it turns out to be 3.3 millimeters, which I now recognize as the diameter for a M4 tap threadable hole. So I can thread these or tap these to M4 thread, and then I can it'll be easier to attach them to the bracket because the screw can go in from the outside and bite into the thread on the inside, so I won't need to have a lock nut or anything on the inside of the assembly, so it'll make everything quite a bit easier. Okay, I've just finished making the first of the brackets that's going to connect the lead screw nut to the plates, or this plate in particular in this case, and it didn't really go very well, mainly because I'm not sure if it's my drill press or this old drill bit that I bought, that 10mm drill there. I bought that on Trade Me about 10 years ago, and it was secondhand, and I don't know what treatment it's had, but it might be a little bit off center because it was wobbling around like crazy, and you may be able to see there the edge around the nut is a bit of a mess, and I've had to widen it with this circular file to get it in the right place. But anyway, everything is perfectly lined up now, so this one should be good, and there's just a couple of holes that fit into the a couple of screws rather that fit into the water jet cut plate, and that's the front of it there. So this is going to be sliding that way. This is the Z-axis base, and it's looking pretty good at this point. Only trouble is now I have to make another 7 of those. So this is what this structure is going to look like when it's done. There'll be a plate on each side, and then using these 4 screws here I can adjust the friction, I guess you could say, on the 2 lock nuts. It'll bring them closer together or further apart, whichever I need, in order to get the right kind of tightness around this, and also reduce backlash. That's the idea. But it's going to be a bit tricky to do this because I found that there's a very, very small range of movement. Each one of these nuts, these screws here, if I move it just a tiny bit, like a quarter of a turn, it can go from being too loose to being too tight. Even just by hand, if I turn this a little bit there, now it's too tight. It's less than a quarter of a turn on the screw. Now it's too loose, actually. So this is going to be very tricky to adjust, I think. That's about right there. So this is good now, but trouble is I need to get
I need to make these screws lock in place somehow, like with a lock nut or thread locker, because I don't want them to come loose. And it's a bit awkward because there's no way to really get a lock nut on there because there's not enough room next to the screws. So this could be a job for lock or thread locker glue, which I don't really want to use, but might have to. So when it's all put together, this is what one of these little units is going to look like, and hopefully you can get the idea there. So the screw will turn, slide it one way or the other. Unfortunately, it looks like these pieces of angle are a little bit thin, because even though I can get rid of the backlash quite nicely, when I grab hold of the screw and push it one way or the other like this, is actually bending this piece of aluminium here a tiny bit. You should be able to see that the gap between these two pieces here is widening when I push it to the left. So that's not ideal. So it might be necessary to put a block in between here so that the vertical piece of aluminium angle here is actually pressed hard up against this side, and something in the middle as well to stop it from moving that way. So I'm just doing a test fit of that lead screw bracket underneath here to see how much friction or otherwise it's giving me. It's not too bad. It's more friction than I'd hoped for. So I'm starting to think these motors are not going to cut it. Might need something bigger. But it will probably be able to turn it enough to move the Z-axis along like this. And having a problem here, and I think it's just the slight vertical difference between the motor. It's all just sort of sitting here at the moment. The vertical difference between the motor and the center of this pillow block, it's not attached properly, and as it is like that, I can get to the end of the run without any change in difficulty. But if I bolt that down, then it becomes very difficult to get to the last sort of 4 or 5 centimeters in this direction. So it's probably a fault of my, I'm not sure if it's a fault of the way that I've made the brackets underneath there, or if it's just the fact that this motor pushing down there on this coupling is not going to be able to. No, that shouldn't be a problem, should it? But in any case, I'm going to try putting some washers underneath this pillow block to lift it up a little bit, and if it can stay where it is there, it should be fine. Okay, with the washer underneath it, it's much better, so I can get it up to right up to the end without any difference in friction. One thing that I am a little bit worried about is that as I move it up and down, I can feel a little spot of friction every now and then, but it doesn't seem to be consistent. So I'll go this way and then I'll come back and there'll be a bit of friction, then I'll go do it again and there's no friction the next time. So I'm hoping that maybe that's just a bit of grubby stuff on here that's affecting it. Oh, actually I shouldn't hope that, but I'm thinking that that's what it is. Anyway, I think I might connect this motor up and see if I can move it up and down using the motor and see how much current it is drawing to do that, because that'll give us an idea of how hard the motor has to work to do it.